So enzymes speed up a chemical reaction by lowering the activation energy. We are now going to look at how temperature affects these enzymes. So we're using catalase again, just like we did in the first experiment from a potato, right? Potato smoothie. And what I did was I took 1 ml of this catalase and I put it into 3 test tubes, and it's been sitting in a different temperature environment for a while. You've got ice, which is freezing cold for number 1, right? This is ice cold. Then you have test tube 2, which has been sitting in an incubator, think like warm bath water. Right? And then 3 has been boiling, which you can kind of see, right? This has been in boiling water for, a little while. So what we're going to do is use the hydrogen peroxide, add it in here, and see what happens, right? How does temperature affect these enzymes? So we'll start with 1. So I'm going to add in a couple mils here. Test tube 2, I'll add in a couple mils here. Test tube 3, couple mils there. All right, and we're gonna see what happens. So if you're looking already, you can see that there's some activity in test tubes 1 and 2. All right, we are producing oxygen bubbles during this reaction. So again, remember we are using a potato as opposed to a human. This potato does not produce its own body heat, right? So its temperature is going to be a little bit different. Remember, all enzymes really have an optimal environment. They have a homeostatic environment. They have an optimal temperature, an optimal pH, an optimal everything. So as we watch this go, what you will be doing in lab is taking a trusty dusty calculator. I just call this calculator. This is called a measuring stick. A ruler, oh my goodness. So you will be measuring how many bubbles are actually made here. All right, so how many bubbles are made from the top of the fluid to the top? And again, you're gonna do this in 20 seconds. So I'm not gonna make this super scientific right now. You will be measuring these in lab. So what you can see just by comparing them, that with the potato, the enzyme is working very, very, very well with ice water, right? Potatoes often live under the ground. So that does make sense. Then test tube 2, which is that kind of warmish temperature, is working pretty well, right? It's doing all right. But 3, nothing. Why? It was in boiling water, right? Test tube 3 was the one that's in boiling water. So if you've got this sitting in boiling water, the structure of the enzyme physically breaks down. So remember, an enzyme is a protein, right? So it has a quaternary shape. You can denature that protein in many different ways. Boiling is one of them. So if you cook the enzyme, you break the hydrogen bonds, and that results in the enzyme not working, which we're confirming here. What we're also confirming is that potatoes actually work in 2 environments pretty well. In humans, that's not always going to be the case, right? In humans, we would basically only work best at our body temperature. Outside of that range, our enzymes are not as effective. So what we are looking at here is that potato enzymes have a range, right? Their homeostatic environment is a little wider than ours as humans definitely would be. But anything, no matter if it is human or potato or mushroom or bacteria, if you boil it, is denaturing. It's not going to work at all. That does not matter, no matter what organism you have.